Structural isomers are fascinating molecules that share the same molecular formula but have completely different atom connectivity. This means they have the same number and types of atoms, but those atoms are bonded together in different arrangements. So what exactly are structural isomers? They are molecules with the same molecular formula but different atom connectivity. The key difference is that the atoms are bonded in a different order or arrangement. Think of it like having the same building blocks but assembling them in different ways to create distinct structures. Let's look at a simple example using the molecular formula carbon-4-hydrogen-10. This formula can create two different molecules. First, we have butane, where the carbons form a straight chain. Carbon-hydrogen-3, carbon-hydrogen-2, carbon-hydrogen-2, carbon-hydrogen-3. Second, we have isobutane, where the carbons branch. Carbon-hydrogen-3, carbon-hydrogen with another carbon-hydrogen-3 attached, carbon-hydrogen-3. Same atoms, different connections. It's important to understand the difference between structural isomers and stereoisomers. Structural isomers have different connectivity, meaning atoms are bonded to different partners. Stereoisomers, on the other hand, have the same connectivity but different spatial arrangements. The key takeaway is that structural isomers have atoms bonded to different partners entirely. There are three main types of structural isomers. First, chain isomers, which have different carbon skeleton arrangements. Second, position isomers, where the functional group is located at different positions on the carbon chain. Third, functional isomers, which have entirely different functional groups. Each type represents a unique way that atoms can be connected differently. Chain isomers have the same formula but different carbon skeletons. For carbon-5-hydrogen-12, we have three possibilities. Pentane is a straight chain. Carbon-hydrogen-3, carbon-hydrogen-2, 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 carbon-hydrogen-3. Isopentane has a branch. Carbon-hydrogen-3, carbon-hydrogen with a carbon-hydrogen-3 branch, carbon-hydrogen-2, carbon-hydrogen-3. Neopentane is highly branched. A central carbon with 4 carbon-hydrogen-3 groups attached. Position isomers have the functional group at different positions. Using carbon-3-hydrogen-8 oxygen, we can create two alcohols. One propanol has the hydroxyl group at the end. Carbon-hydrogen-3, carbon-hydrogen-2, carbon-hydrogen-2 hydroxyl. 2-propanol has the hydroxyl group in the middle. Carbon-hydrogen-3, carbon-hydrogen with hydroxyl attached, carbon-hydrogen-3. The functional group is the same, but its position changes. Functional isomers have different functional groups entirely. With carbon-2-hydrogen-6 oxygen, we can make two completely different compounds. Ethanol is an alcohol. Carbon-hydrogen-3, carbon-hydrogen-2 hydroxyl. Dimethyl ether is an ether. Carbon-hydrogen-3, oxygen, carbon-hydrogen-3. Same molecular formula, but completely different chemical properties due to different functional groups.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.